In this module, we will do some case studies where you will understand that why the unit testing is important in Typescript projects and what kind of projects undergo what kind of testing, what are the advantages of the testing and what went good and what did not go good. We will be checking everything. So let's look at these real world examples. The first case study is that unit testing in a TypeScript based microservices architecture. So microservices architecture means that where individual applications are being deployed separately which are independent of each other. Okay, they are doing their thing, they are not dependent on anyone. So that microservices architecture has been used in that project for the backend side. And here, as you see, a company building a microservices based e-commerce platform uses TypeScript for both backend and the frontend. So React.js plus TypeScript and Node.js with TypeScript as well. So the microservices handle various aspects like user management, payment processing, order management. So there was a service for user management, there was another service for payment processing, and there was service for order management. All of these were deployed as separate applications. So for testing, they chose Jest. As you can see, Jest was chosen as the testing framework due to its rich feature set and seamless integration with TypeScript. Okay, so here, as you can see, that tests were written for individual functions within each service, covering a variety of edge cases. Mocks and stubs were extensively used to isolate services during testing. So mocks we have already studied in this course. You can go back and go to the mock section. So mocks we have already studied. So now here, what were the lessons learned? I mean, what does it want to convey here? It wants to convey that the first one was that importance of mocking external dependencies. So mocking allowed the team to isolate the services, ensuring that tests were reliable and fast. However, over-reliance on mocks sometimes led to tests that didn't catch integration issues. I will tell you what are integration issues. So see, we already saw in this course that we can mock the dependencies, we use the XCOs and we mocked that, right? In the same way, they also mocked their external dependencies that they were using. So that using the mocking, their tests were actually fast and they were quite reliable. However, excessive mocking caused the integration issues, means that whenever there was an integration of a feature, say you are doing integration testing, means there is one particular component or particular feature that you are testing, there it caused some issues. Alright, now the test coverage and the test quality. So initially the team focused on achieving high test coverage, but soon realized that high coverage doesn't necessarily mean high quality test. Alright, so see, high coverage means what? That you are testing each and every line of your code. Okay, that's fine. However, the quality matters the most. Maybe the tests that you have written are so basic that even though the coverage is high, your tests are not testing every kind of scenario. You may not be having test cases for everything like that. So here they shifted focus to writing meaningful tests that covered critical paths and the edge cases. Now here are some common pitfalls. What went wrong? Mocking too much. Some tests were too isolated, leading to missed integration issues. So basically, whenever there was, any feature testing or any component testing where you are doing integration testing. So what happened is that whatever issues were there were missed. Why? Because you are simply mocking the dependencies, you are mocking the behavior. You don't know how they are actually behaving in your component. A balance between unit and integration testing was crucial there. And test maintenance overhead. As the codebase grew, maintaining tests became challenging Especially when refactoring, the team learned the importance of keeping tests simple and clear to reduce maintenance costs. Alright, so what happened here was that when they were writing the tests, they had to make sure that the tests had a better quality. I mean, proper naming conventions were there, and apart from that, the test covered everything. But the code quality was so beautiful, like it looked like a self-documented code, so that if any other developer is coming to work on it, they do not face any problem. As you can see in the last line, I'm reading again. The team learned the importance of keeping tests simple and clear to reduce maintenance costs. Exactly. They had to keep the tests simple as well. I mean, more complicated tests will only result in issues, because if you are creating any complicated test, means like you are testing multiple things in just one test case, or like you are testing for one particular case. I mean, that will not be a good practice for unit testing. So yeah, this was our first case. Moving on to the second case study, unit testing in a TypeScript React application. Alright, so now this is for the front end side. A team built a large scale React application using TypeScript, and the app had a complex state management system and many UI components. Basically, there were too many components and that must be interacting with each other, so that they had to maintain a state management system, and that was quite complex because changes that were made in this one component can be reflecting in multiple other components as well. Now here you see the testing approach was React testing library and Jest were used to write unit tests for components. Initially they were trying to consider Enzyme. Enzyme is another library for testing. However, they used React testing library. Why? Because it has better support for the React hooks and modern React features. Alright, modern React features, like you have that fiber algorithm in the React and automated state batching and all like that. Enzyme doesn't have that. So that's why they chose React testing library, and that's why in our course as well we had covered the React testing library. Now the test focused on both component logic and rendering with mocks used for API calls. So for the API calls they had to use the mocks, and the focus was also there on component logic and rendering. Lessons learned. Testing user interactions. Now they were testing the user interactions, like a user is hovering or clicking or maybe submitting a form like that. So we had already covered how to test the user interactions in this course. React testing library made it easier to test user interactions, leading to more reliable tests that mirrored real user behavior. So they had to imitate that real user behavior, and for that they use a React testing library, and we already know how to do that in the previous modules on testing the React.js applications. We have already done that. So in the same way they also did the same thing. Now focus on testing behavior, not implementation. The team shifted from testing implementation details like component state to testing user visible behavior, leading to more robust tests. So see, I mean the user does not care that you have used state or refs or whatever. They just want a perfect application. They just do not want to face any problems. So as a user they thought, and whenever they were writing the test, they were thinking from a user's perspective, and in this way they wrote their tests. Now there were some common pitfalls. Testing with mock APIs. Mocking API calls sometimes select to tests that didn't fully represent real world behavior, particularly asynchronous operations. So see, when you're mocking an API call, you had to make sure that each and every detail is point to point perfect. The payload is exact. The way you are calling that API is completely same as what you are doing in that application. So while mocking the API calls, the focus was too much on ensuring that the design of the test cases was exactly the same way as if they were doing the real API call. Component re-renders. Tests that didn't account for component re-renders sometimes passed falsely. The team learned to consider React's rendering behavior in the tests. Alright. So, what does it mean? The re-rendering behavior, like whenever any state is changing, the component re-renders, or in the use effect, you pass the dependency array and pass the dependencies. In that way, they had to imitate the React's rendering behavior in their tests as well, so that all the test cases should pass by determining the exact component re-renders. Okay. So what were the general lessons and common pitfalls in the Typescript unit testing? So if I talk about the lessons learned, like type safety in test, TypeScript type system can prevent many common errors in tests for sure. Since TypeScript gives you type safety, it creates a robust code so that you know exactly what you are doing. Leveraging TypeScript's strict type checking tests can catch the issues early. Alright, so before actually running your command npm run test, you can see in your IDE if there is any issue, and it will not let you compile the code as well. Balancing unit and integration tests. So pure unit tests can miss integration issues for sure. A balanced approach combining unit integration end-to-end tests often yields the best. Integration testing means you are testing particular feature or component. End-to-end means testing entire application. And unit test, testing the individual parts, testing one component like that. And clear and concise tests. So tests should be easy to understand and maintain. So that you have to write tests in such a way that if any other developer is coming to work, they are able to understand that for what this application is built, what exactly is happening inside the application, what is the behavior, expected behavior. Simple focus tests are usually more maintainable than complex multifaceted ones. So by simple focus test means that one test case should cover one thing only. In a test suite you can cover multiple things, but in test case you cover only one thing. In test case you are doing multiple things, then it becomes complex. Common pitfalls overall. So over mocking. Now you're mocking API calls, you're mocking dependencies. Over mocking can lead to false behavior. Excessive use of mocks can lead to tests that pass even when the real code would fail. Exactly. So when you're mocking, you need to take care that you are imitating the exact behavior of the application. It is important to test with real dependencies where possible, particularly in the integration tests. Ignoring edge cases. So if there are edge cases, let's say thousands of requests are coming concurrently, or let's say like if the data is not there, then how things will render. If something is coming as undefined or null, and you are reading some properties from it, how are you going to handle that? So many edge cases had to be taken care of. In test maintenance, as the code base evolves, tests can become outdated or irrelevant. Regular review and refactoring tests are important to keep them effective. Alright, so see, the application behavior might change, but you might be having the same old test cases testing the features or even the components that no longer exist. So in this way, you need to continuously refactor your tests and make sure that all of those are the latest ones only. Alright guys, so this was it from the case study, and yeah, with this we have almost finished our course. In the next session, in the next module, basically we are only going to see conclusion of our course. You will be finding all the content, like all the notes that I have made, so you will be finding a complete handbook of that, and apart from that I will give you the repository link. I'm already giving in the description. I will still guide you through like that. So yeah, thank you for being in this way. Congratulations on completing this course, and yeah, if there is any doubt, keep asking. No issues. Thanks.